Hello, hi. Today we shall be developing Johansen test of co-integration, right? Using our software. Using our software. Okay. Okay. Now we first see our R software. The R software is available here. You can see this one is the R software. You can see R console, and here we can write the program and can upload R software. Okay, so first I write the command. First I have to install packages from online. So the package name is Urka, right? The Urka, so that is the package name. Install packages Urka, then enter. So the package is being downloaded. So then I choose my area, then I press OK. So the package is being downloaded gradually. So okay, it is going on gradually, and this R software is a free software, so we can easily download online. Okay, afterwards I have to write the command library urka, right? I have to write this command, then enter. So then afterward I have to find out my data. My data is located, read CSV, and it is under C drive, and the folder name that I have is econ3, and the file name is lot and CSV file, and my data file is a CSV file in nature. Okay, it is in the CSV file in nature. So and it is located in C drive. So we have done it, then enter. Okay, then I have to attach my data. Okay, now I want to see the data. My data file name is lot, and I want to take a read the CSV file and write file dot choose, then first bracket, second bracket, then header equal to true, right? Then enter. Okay, then it is entered. So my file is located is in the C drive. So where is the C drive? I go to C drive, then under econ3 folder, it is available. You can see the file, lot file here. So I give a click here, so the data is coming up gradually. So then you have to write the file name lot, then enter. So the data has been appeared here. You can see the data is from 1960 until 1995, and we have three variables. One is cons and one is ex and one is GDP. We have these three variables, and we want to run Johansen test of cointegration using these three variables. Okay, here one thing we have to know. So we have three variables, cons, EX and GDP. Okay, and we want to run the Johansen test of cointegration, but there is one condition before running Johansen test of cointegration. And what is the condition? The condition is all the variables should be non-stationary, but when I convert all the variables into first difference, they will become stationary, and if that happens, only then we can run the Johansen test of cointegration. Okay, but here we assume that without checking that cons, EX and GDP are non-stationary data, but if I convert them into first difference, right, if I convert them into first difference, they will become stationary. Okay, that I assume without checking and testing. So meaning that we have fulfilled the condition of Johansen test of cointegration. So we can run the Johansen test of cointegration because all the three variables are non-stationary, but when I convert them into first difference, they are stationary. So we can run the Johansen test of cointegration. Okay, so and there are, what I do first. Okay, so there are actually two tests. One is trace statistics and one is eigenvalue statistics, right? And we shall be applying both these tests. Okay, so first what I do, first I come back to my command. Okay, first I take LL as C bind. That means this LL can represent cons, EX and GDP, meaning that LL can represent all the three variables from this command. So I can now easily run Johansen test of cointegration. Okay, so first I run the trace statistics, that I do first. So I take H1 as my first test. Okay, so the command is CA Johansen cointegration. Then I put my LL, right? then I put type. Type is what? Trace statistics, that we shall do first, then comma, then ECDAT, and here I take only constant, meaning that I assume that all the data has a sorry, here I don't take constant, here I take something else, not constant. Just 1 minute. So here I take none, not constant, I take none, right? And then k equal to 2. Okay, what does mean by none? None means I say that there is a linear trend in the data that I assume. So that is why I have chosen none. And here K2, number of lakh. Suppose lakh selection criteria has advised me to take lakh 2. So I have taken lakh 2. So here I take lakh 2. Then we are done. Type trace ECDT none. That's done. Then I press enter. Okay, then I have to write summary of H1, right? Enter. So that the result has come up. You can see Johansen procedures. So it is that trace statistics with linear trend in the data, and you can see eigenvalue statistics, and these are the value of test statistics and critical value of test. And here is the R is what? R is the number of co-integrated equation. So here is 2, here is 1, and here is 0, meaning that there is no co-integration, that is R0. Okay, here you can see this test is what? This test means test statistics. So these are all test statistics, and these are 10%, 5%, 1% are the critical value of this test statistics. And here we shall select the 5% as a benchmark. Okay, so and what is our null hypothesis? Null hypothesis is there is, suppose I talk about this one R0, meaning that there is no co-integration among the three variables that we have. That is the null hypothesis. And what about this one R1, meaning that there is co-integration among the variables and there is one co-integrated model among these three variables. And here is R2, meaning that all the variables are co-integrated and there are two co-integrated equation in the model. Okay, so we check one by one. Okay, first I take R0. So what is the statistics? 45.17%, which is more than our critical value 31.52. So when the test statistics is more than critical value, we can reject the null hypothesis and can accept the alternative hypothesis, meaning that r equal to 0 is not correct. We can easily reject r equal to 0 because test statistics is more than critical value. Okay, then we come here. R is equal to 1, and how much is the test statistics? 10.57, which is less than critical value, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that R is equal to 1, meaning that our three variables such as cons, EX and GDP are co-integrated, meaning that they have long run associationship. So it is already settled, they have long run associationship. So we can run the error correction model because all the three variables are co-integrated. Okay, and here is one co-integrated equation, because R is 1 means there is one co-integrated equation. Okay, according to trace statistics. Okay, now I check eigenvalue test, right, that we can do now. So I proceed as before. Okay, and the command would be as before. Just 1 minute. Our command should be exactly as before. Okay, so I write here h1 as before, then CAJO bracket close, and file name is LL, not file name, LL. We have already done it before, and the type is eigenvalue, right? Eigenvalue statistics, and ECDAT is none, meaning that there is a linear trend in the data, and number of lag I put here as before. So it is set, enter, then summary H1. So the outcome is coming up gradually. Press enter. You can see the Johansen test, and it is the maximal eigenvalue statistics, and you can see everything is as it was, with a linear trend is there. Okay, so this one is the R is 0, meaning that there is no co-integration among the three variables, and here is the test statistics, right, and these are the critical value as before, and here 5% is our target all the time as before. Okay, now I check the first one. The null hypothesis is R equal to 0, and here the test statistics is 34.60, which one is more than 21.07, meaning that we can reject the null hypothesis, which is r equal to 0. Okay, now we can check the second null hypothesis, that is r is equal to 1, and here is the test statistics is 8.24 and the critical value is 14.90, and when the test statistics is less than critical value, we cannot reject null hypothesis, rather we accept null hypothesis, meaning that r is not 0, it is equal to 1, meaning that r is equal to 1, meaning that all the three variables are co-integrated, and there is one co-integrated equation. Okay, so what is our ultimate decision after the trace and eigenvalue statistics? So what is the ultimate result? That all the three variables are co-integrated, or our three variables such as cons, ex and GDP move together in the long run, meaning that they have long run associationship. So we can run the ECM or VECM model, because all the three variables are co-integrated or they have long run associationship. So thank you very much for being with me for a while.